Sometimes integrals can be challenging to evaluate by hand, but we can use a list of already established integrals to help us evaluate these. That's what we're going to be doing in this video. Sometimes we need to manipulate the original integral first in order for it to fit one of the forms in our lists. In this case, we want to do a u substitution. Let's let u be e to the x, then du is e to the x dx. Now rewriting this integral, we have the integral of u divided by 4 minus u squared du. Now we can look through our list of integrals to see which form this fits. Rather than show you an entire list of formulas in this video, I'll just show you the one that we're going to be using here. And in this case, I'll make a note that this is number 19 in our list. We'll use 1 divided by 2 times a, which in this case is 2, times the natural log of the absolute value of u plus a, which again in this case is 2, divided by u minus a, which is 2, closes off the abs value, and plus c. Now we'll just go in and simplify. We have 1/4 natural log, absolute value. Replace the u with, in this case, we said u was e to the x. Do that again in the denominator. Replace u with e to the x. Add that plus c. And we've got it. In our next example, there's no simplifying that we need to do first. We just need to find the form in our list of intervals. And again, I'll just give it to you in this particular video. We're going to be using rule number 74 to begin with. We have 1 divided by n in this case is 6, times the cosine of n minus 1, that's 6 minus 1, which is 5, u, which in our case is theta, sine theta, plus n minus 1, that's 6 minus 1 is 5, divided by n, which is 6. Then we're multiplying by the integral from 0 to pi. Cosine of 6 minus 2 would be 4 theta d theta. This first part, we actually need integration limits. Almost forgot that. We're going to need the rule again on this piece. Same rule, so we'll do 74 there. And we can go ahead and evaluate this first piece. Notice that sine is going to help us. Sine of pi is 0, so that upper limit part will go to 0. Then if we plug in 0 to sine, we'll get 0 again. So that all goes away to 0, plus 5/6 on the outside of the integral, and now we'll use that rule again, which is 1 divided by n. N in this case is 4. Cosine of n minus 1, that is 4 minus 1, which is 3, theta, sine theta, and we'll close that off. This piece we will evaluate from 0 to pi, plus n minus 1, that's 4 minus 1, which is 3, divided by n, 4, integral 0 to pi, cosine of n minus 2, 4 minus 2 is 2, then theta d theta. At this point, we have cosine squared. We use a new rule this time. This time it's going to be rule number 64 here. Bring down the 5/6. Again, we can evaluate inside the brackets. Sine of pi is 0, so that goes to 0. And then if we want to subtract the lower limit, plug in 0, and again we get 0. So that's, again, quite helpful. So we have 0 plus 3/4, and now we'll use this rule to evaluate this limit. we have 1/2 u, which again, theta in our case, plus 1/4 sine of 2 theta. And we are evaluating from 0 to pi. Let's simplify this. We'll have 5/6 times 3/4 times, let's go in and do a little bit here. If we plug in pi to theta, we'll get 1/2 pi, or pi halves. Plugging in pi to this piece will go to 0. Then if we plug in 0 to both of those, will be 0, so that goes away. We're left with just pi halves. Simplifying all of this, and we get 15 pi over 48, and that will reduce, that will give us 5 pi 16ths. In this example, we'll manipulate the integral a little bit to make it look like one of the forms in our table. We have x to the 4th divided by the denominator we want to rewrite. We'll write x to the 5th squared minus 2. From here, we can do a u substitution. We'll let u be x to the 5th. Then du is 5x to the 4th dx. We'll need to divide by 5, so that is 1/5 du equals x to the 4th dx. Now rewriting with our new variable, pull 1/5 out front, it's just a constant. We have 1 divided by the square root of u squared minus 2 du. Now looking through our table of integrals, we have rule number 43 here. 1/5 stays out front. Using the table, we have the natural log of the absolute value of u plus the square root of u squared minus a squared, which in this case is 2. Close off the bars, and plus c. The only thing left to do now is to rewrite this in terms of x. We have 1/5 natural log, absolute value. U, we said earlier, is x to the 5th plus the square root of u squared, that's x to the 5th squared, which is x to the 10th, minus 2 plus c. Close off those absolute value. In this example, we will start by making a u substitution. Let's let u be x to the negative 2. Then du is negative 2x to the negative 3 dx. If we divide by negative 2, we get negative 1/2 du equals x to the negative 3 dx. Now going back to the original, we can now rewrite it. We'll pull the constant out front, integral of inverse cosine u du. At this point, we'll look through the table of integrals. And again, I'm not going to scroll through all of them in this video. I'll just give you the one that we need here. I'll indicate that this is number 88 in our book. And let's use it. We have negative 1/2 out front. And then using the rule, u inverse cosine of u minus the square root of 1 minus u squared plus c. All we have left to do now is resubstitute what u is. Negative 1/2, u is x to the negative 2. inverse cosine of x to the negative 2 minus the square root of 1 minus x to the negative 2 squared is x to the negative 4th and plus c.